Alright, in this video what we're going to be discussing is solving quadratic equations by factoring using GCF and inspection. So what we've got right here is 2x squared minus 8x plus 6. So what we're going to do in this one, we're going to be looking to see first and foremost if they share something. They all share a 2, so what we're going to do is we're going to go ahead and pull a 2 out of that. So what that means is I'm just going to evenly divide each of these by 2. That 2 is not going to disappear. I need to put it out front to make sure that it's all set up correctly. And then on the inside of my parentheses, what I'm going to do is I'm going to write whatever's left after I divide by 2. So 2x squared divided by 2, for example, that just cancels out the 2's and leaves me with x squared. Then I have negative 8x divided by 2, and so I'm going to reduce that. Negative 8 divided by 2 gets me negative 4, and I'm just bringing the x down. And then 6 divided by 2 is 3. So this is what I have left. Okay, so now I've kind of helped myself a little bit here, and so now what I can do is I can solve using our box method. And so that's just factoring. So that means that what I'm going to be doing is I'm going to be taking this part right here inside the parentheses, and I'm going to be figuring out how to solve that. And the first thing I have to do is I have to do 1, so I have to do A times C. So 1 times 3. And so I have to figure out whatever multiplies to get me 3. And what I've got to figure out to do with that is it has to add to get me whatever my B value is. And in this case, B is negative 4. So I'm going to go ahead and write that like that. So now I have to figure out everything that I can multiply to get 3. And really, that's quite easy. It's just 1 and 3. So I have 1 and 3. Well, 1 plus 3 doesn't equal negative 4, does it? So maybe try negative 1 and negative 3. Negative 1 plus negative 3 gets me negative 4, and negative 1 times negative 3 does equal 3. So I'm set with that. So now what I'm going to do is I'm going to set that up in my box, just like this. And so whatever it is that you found that you multiplied together and add together, you put in the box on the diagonals like this. So I have negative 1x and negative 3x. You have to add the x there because all we were doing was trying to get to this x part right here. So now what I'm going to do is I'm going to go ahead and put over here in the top left corner, I'm going to put what I was starting with for my a value right here, so that 1x squared. So I have 1x squared. You could also just write x squared. I'm just putting the 1 there to kind of help us visually. And then right here, this one right here is always going to be whatever that C value is. So in this case, C is 3. So I'm going to write 3 right here. So now what I'm going to do is I'm going to go ahead and I'm going to pull a GCF out of each row and each column. So what that means is I'm going to look right here at this very first row, and I'm going to go, what does 1x squared and negative 3x share? Well, 1 and negative 3 don't share anything but 1. But x squared and x share an x. So I'm going to write that over here. And then right here, in this row right here, negative 1x and 3. Again, they don't share anything, except this time they don't even share an x, so they just share a 1. But since there's a negative 1 right here, since it's on this outside corner right where I'm going and pulling things out, I'm going to go ahead and pull that out. If it was a positive 1, I would write plus 1. If this 3 was negative and this was positive, then I wouldn't pull out a negative. But because it's right here, it's touching this side that I'm pulling from, I'm going to go ahead and pull out that negative 1. Now from this column right here, I have 1x squared and negative 1x. They share an x. See, notice here, I didn't pull out the negative, just like I didn't pull out a negative here in this one. Right here, I've got negative 3x and 3. They share a negative 3. See, I'm pulling out the negative right there because it's touching this side that I'm pulling from. And it doesn't matter what's going on over here with this one. So I'm pulling from this outside corner right here. So what this ends up simplifying down to is all of this in the parentheses, this 1x squared minus 4x plus 3 becomes, and I take this part right here, it becomes x minus 3. And then I have right here this part, this x minus 1 part, and it just becomes x minus 1 right here. Now, that's just the part that's inside the parentheses right there. Remember, I have that 2 on the outside, and I also have it equals 0. So I really have 2 times this, and it equals 0. So I have 2x minus 3 times x minus 1, and it all equals 0. And the way that I take that from there to solve the way that I kind of rate things, my own personal thing, is I divide it up. I set it up and go, okay, so I've got a couple barriers here that I've got to set up, and I've got different equations. So I have 2 equals 0, and then I have x minus 3 equals 0, and then I have x minus 1 equals 0. I always set up those little barriers right there wherever I have a whole number that I'm going to be taking and setting that equal to 0. Now remember, this is technically, I have 2, that's a number, and then I have x minus 3, that's another number, so you can plug any number in for x, right? You plug in 586 in for x, and 586 minus 3 is still going to get you a number, 583. X minus 3 is just a number. And then same thing, x minus 1 is just a number. So I have 3 numbers being multiplied together, and it has to equal 0. So in order to have one of them have the whole thing equal 0, one of them must equal 0. So that's what I'm setting up right here. So what I'm going to do from here is I'm going to go ahead and I have 2 equals 0. Well, that doesn't matter. That isn't true. That's not going to be part of that. And so then I'm going to solve x minus 3 equals 0. And I'm going to solve that. And in order to do that, I'm just going to go ahead and add 3 to both sides. And that's going to get me x equals 3. And then I'm going to go ahead and set up my other one, which right here is x minus 1 equals 0. So I have x minus 1 equals 0. And I'm going to set that up and solve that. And so I'm just going to add 1 to both sides. And so that's going to give me x equals 1. So my final solution is either x equals 3 or x equals 1. What I mean by that final solution, we're going to put that into the calculator. And we're going to see what it does. So what I have here for my original equation is I have 2x squared minus 8x plus 6. So let's plug in, and instead of having 2, oh, where did my calculator just go? So instead of having 2x squared, I'm going to plug in for x, and I'm going to say 3, because that's what we found that it is. So I'm going to say I've got 3 right there, and we're going to square that minus 8, and instead of x, I'm going to plug in 3 and plus 6. And if I solve this correctly, I'm going to get 0 back, because that's what the equation says. It says that for any value that I plug in for x that makes this a true statement to be equal to 0, we have x equals 3, for example. And sure enough, it does equal 0. So let's try again and plug in instead. We're going to plug in 1. So what I'm going to do here is instead of x, I'm going to plug in 1. And then we have minus 8 times 1 plus 6. So you see what I did there is I just took the whole equation, and instead of x, I'm plugging in what I found x to be. And sure enough, it equals 0 there too. So since it equals 0, my statement is true, and I solved it correctly. Let's try a different one. How about let's look at this number 7 that we have right here. So let's go ahead and look for a GCF. I can evenly divide 6 by 1, 2, 3, and 6. But 29, that's a prime number. I can't divide anything out of 29. So what I'm going to go ahead and do is I'm going to go ahead and just kind of keep it as it is. So this one doesn't have a GCF. So now instead what I'm going to do is I'm going to go ahead and I'm going to take this first number here and I'm going to multiply it to here. This is A times C. So I have 6 times 9, which is 54. So that's the number that I've got up top, and I've got to figure out what I can multiply to get, or what multiplies together and adds together. Okay, so what multiplies to get 54, but adds together to get 29. So it's got to add to get that B value. So what I'm going to do is off to the side, This is my little trick, and I do this if I ever don't know the exact number that I've got to multiply together and get something. So what I'm going to do here is I've got 54, and so what I'm going to do is I'm going to go, okay, so what's 54? Divided by, and I would start with 1. Well, obviously I know that that's going to be 54. So I've got 1 and 54. Well, what's 54 divided by 2? So we'll do that. Divided by 2. It gets me 27. So I've got 2 and 27. Well, shoot, right there. 2 and 27 adds together to get 29, doesn't it? So I can stop. I don't even have to keep going down my list of all my factors. All I was going to do was 54 divided by 3, then divided by 4, then divided by 5, until I found the right number that gets me what I need to add together to get my B value. So here I've got 2 and 27. So now I'm going to put those in my box. So let's set up our box. And in the bottom left corner here, I'm going to put 2x. I could also put 27x. It doesn't matter. It just matters that I have those numbers in my boxes on my diagonals. Okay? I could have put 27x here and put 2x here. It'd be fine. Now in this corner right here, I put that a value right here, which happens to be 6x squared. And in this bottom corner, I put 9. All right, now from here, what I'm going to do is I'm going to figure out everything that they share in this row. So looking at 6x squared and 27x. Well, I cannot evenly divide 6 out of 27, but I sure enough can pull out a 3. And how about x squared and x? I can pull out an x. So they share a 3x amongst both of these. 2x and 9. Well, I can't do anything with 2x and 9 except for 1. Remember, if you can't pull out something, it's always going to be 1. Could also be -1 if that negative is on the outside there. All right, let's look at this column right here, 6x squared and 2x. Well, I can evenly divide 6 by 2, so I'm going to pull out a 2. And x squared and x, I can pull out an x. Now right here in this column, I have 27x and 9. They both share a 9. I can evenly divide 27 by 9, and I can evenly divide 9 by 9. This one has an x, this one does not, so I cannot pull out an x. So now I've got the things that go into my parentheses. So I've got 2x plus 9 and 3x plus 1. So that's what I've got right here, and I got to set that equal to 0 because that's what we started with right here. So now I've got 2 little things inside my parentheses, and now I'm going to set it up as 2 equations. I've got 2x plus 9 equals 0, and I've got 3x plus 1 equals 0. So now in order to solve those, all I have to do is get everything over to the other side. So I'm going to subtract 9 from both sides here, and that's going to get me 2x equals -9. And then I'm going to divide both sides by 2. And I get x equals -9/2. All right, and I'm going to do the same thing over here, get x by itself, so I'm going to subtract 1 from both sides. That gets me 3x equals -1. And then I'm going to divide both sides by 3. And that's going to give me x equals -1/3. So those are my final solutions, -1/3 and -9/2. Again, I can check my answer, make sure that I've got it right. So all I do is I start with the equation that I started with, and instead of x, I just plug in one of my answers. So for example, I've got 6, and instead of x, let's do -9. Oop, sorry, that's going to do a subtraction. That's not a negative sign. Can't do it from the computer tab. There we go. -9 divided by 2. And that is squared plus 29. And instead of x, I have -9/2. And again, we're adding 9. So this should equal 0. Sure enough, it does. So negative 9/2 is right. Let's check negative 1/3. So I have 6, and instead of x, negative 1/3 squared plus 29 with negative 1/3 plus 9. It equals 0. So those are my correct answers. So all I did was take my information, plugged it in to make sure I was right. I plugged it in exactly how it was written, except instead of x, I put parentheses and whatever value it was that I found equaled x. Hopefully that clears up some questions that you guys might have. If you don't, or if you have any more questions, just let me know.